All right, so for today's work, or this week's work, we're going to be looking at crime in Chicago. I had wanted to do crime in some Alaska city, but Alaska doesn't disclose its crimes to the extent that places like Chicago does. Portland has some crime information. Again, the database isn't as robust as what Chicago is, so we're going to use Chicago as an example. And so if you go to your course content and you see Chicago crime here, you're going to see that there's a folder, here's a file for a guide. So I'm kind of playing with making guides for each of the exercises. The issue with guides is sometimes as I'm going through and doing the videos, I might not call things exactly the same thing. You know, like I might not name a field exactly the same or a data set exactly the same. So there can be some little differences, but the overall flow of the exercise is there. And so we're going to look at kind of which neighborhoods have the biggest issues with crime, you know, maybe to target some programs aimed at reducing crimes. You know, how has crime changed in neighborhoods between 2010 and 2019? And then we're actually going to do some modeling. So what socioeconomic factors are associated with crime? You know, can we build a model to predict crime? And then lastly, there's this theory out there that parks are associated with crime. You know, in Anchorage, we do have the issue with parks and homelessness, and sometimes people feel that those are criminal hotbeds. Well, we're going to use some of the Chicago data to see if there's an association between the acres of park and the number of crimes that you find within a half-mile walking distance. So if we could get the data, we could do something similar here in Alaska, but we will see. I'm working on it. All right. And you have your crime data, which is a zip file, so you just click on it and it'll ask you to download your data. Download it to wherever you are saving yours. So again, I strongly recommend having a CGIS and then making a folder called crime data or a crime project. All right, so I'm going to open up ArcGIS Pro. Throw this off to the side. I'm going to open it up and then save it as a new project called Crime, Chicago Crime. So I've already saved one, but I'll go through the process here. You go up to Map, and I usually uncheck this Create a New Folder. I'll call it Chicago _ Crime. And come here. GIS, I usually have a projects folder and I'll save it there. So it's saved in my C project Chicago Crime and hit OK. Like with any of these exercises, there are many steps involved. So don't think that you need to sit down and do the whole exercise in one sitting. The beauty is you can just stop wherever you are and save your project and come back and pick it up. So don't feel you need to push all the way through it to the point where you're just getting tired and frustrated and making mistakes and it's not fun. It shouldn't be horrible. All right, so let's go and add data. So this is the data that will be from that unzipped folder that you have. So wherever you've downloaded your folder, unzip it. If you don't know how, I have a video in the kind of help section on Blackboard where you can find out how to do it. So hold down the shift button, click bottom, click top, and then it selects it all and hit OK. Some of the processes in here take quite a bit of time, so I will pause the video as they run and then come back. So if you see me just kind of an abruptness, that's what's happening. All right, so this is our crime data here. It comes as a CSV, which is kind of a stripped down Excel file. See, it does have a lat long coordinate in here and XY. Think of, yeah, Y is kind of your latitude, so up a ladder. There are some nulls, so these ones, yeah, there's crimes, but they didn't get where it actually occurred. Those will be tossed out when we convert it into lat longs. I see they have two different coordinate systems in here. They have an X and Y coordinate, probably in meters, and then they have a latitude and longitude here, which looks like decimal degrees. So we need to convert these into shape files, so points. In order to do that, go up to, or actually just right click on one and go display XY data. And since these are going to be in the wrong projection, they're going to end up in WGS 84, but that's what the data was collected in. We're going to have to reproject them into this Chicago NAD 83. So for now, just hit OK. Keep the default, let it go to your default geodatabase. So you'll do this for the 2010, and then we'll do this for the 2009 or 19 data. And these are pretty big data sets. You'll see a whole bunch of points pop up on the screen here. Alright, so these, they're ignored because there was no GIS location for them, so nothing we can do about it. So yes, a lot of points. And so what we want to get this in is if you right click on a layer and you go down to properties, you can figure out the spatial reference, so what projection was used by going to the properties, source, and we can see that eventually we wanted in this NAD 83 state plane. So we're going to want to project it into that, so just to cancel because I was curious. Alright, now do the exact same thing for 2019. Right click on it, go to display XY data, just accept the defaults and hit OK. So after these get done, these are just temporary data sets, and we are going to want to put them in the correct projection. So to do that, we go up to Tools, Toolboxes, go down to Data Management, Projections, and go down to Project. So we're going to do it for each of these. So 2010 we'll grab first. And you want to save these now for real in a place where you're going to keep them. So if I did have like a folder in here, you know, called Chicago Crime, I would save them in here. Alright, and what I'm going to want to call them is Chicago, I'm going to want to call them crime underscore data underscore 2010 underscore NAD 83, and then hit save. In the output coordinate system, you're going to want to choose the neighborhoods because all of these have the same the same projection. All of these you see have NAD 83 extension. Okay, and then hit run. I'm not going to hit run because this process takes a few minutes to do. You can hit run, walk away, and come back. And then when this gets completed, do the exact same thing for the 2019 data. 2019, change this to 2019. And then again, select the neighborhoods, and then hit run. And it'll pop out your shape files, so I'm going to add them because, like I said, the process takes quite a while and I don't want to repeat it again. So here are what your two files should look like. You should have a crime underscore data 2019 up here and a 2010. I'm going to remove these other ones that have the wrong projection. So click, hold down shift, click, and then right click and remove. Okay. So our first question is, which neighborhoods have the most crime? So I'm going to turn off this layer and the parks layer and just have the neighborhood on. And I'm going to double click on it and give it some boundaries, give it some color here, just so I could maybe move it on top and see. Okay, so there, we can see even the airport has crime, which isn't surprising. Alright, so we want to count up the number of points within each of these neighborhoods. Alright, to do so, We're going to go to Analysis, Tools, and can anyone remember the tool? I think we've used it before. It's called Tabulate in the Intersect tool. So go up to Analysis, Statistics, Tabulate Intersection. I did that kind of fast. Analysis, Statistics, and then Tabulate Intersection. So we're going to double click on it. So we want to know by the parks. So our zone feature is going to be our neighborhoods. We want to know by the neighborhoods. And the zone field is going to be the primary name of the neighborhood. So within each of the neighborhoods, we want to know how many crimes there are. And our input feature class, let's do the 2010 crimes first. And click once on this output table. We don't need to save this file, but we need to name it something we're going to understand. So I'm going to name it, let's see, what should I name it? Tabulate 2010. Okay, so Tabulate 2010. I'm letting it go to the default geodatabase where I created the project. That's fine. But after that last slash, I'm giving it a name I can understand. And then hit run. Then we'll do the exact same thing for 2019, but we'll change the 2010 to 2019. Alright, that tabulate intersection is going to take a while to do. I already have done it, so I'm going to add the data. Remember, do the same thing for 2019. So come here, 2019, change this tabulate to 19, and then hit run. And again, it'll take a while to do, so go grab yourself some snacks or a drink or something like that while it runs, and then come back. Alright, so I am going to add the data that I have. Alright, crime data. Here's my tabulate tables. Alright, so we'll take a look at one of those, right click and go to open. And you can see the name of the neighborhoods and then the total number of crimes in 2010 that had occurred. Okay? We have one of those for 2019. Open. You can see number of crimes, name of the neighborhood. Alright, so now these are non-spatial. We need to join them to our neighborhood GIS shapefile. So right click on your neighborhood one, open attribute table. We're going to want to add a couple of columns to here to store our crime data. So go to add and call it crime 2010, crime 2010, and keep it along. Add crime, crime 2019, crime 2019, and keep it along and hit save. And it gave me an error. I'm not exactly sure why. Alright, so what you saw was an example of classic ArcGIS. I basically had to shut my computer down, restart my computer, and now things seem to be working. I think somewhere within the memory of my computer, ArcGIS was thinking that I had this shapefile open somewhere else and wasn't letting me edit it. So whenever you run into unexplainable errors, save your project, close it, restart, and try again. So we were adding crime 2010, crime 2010, leave it along. Crime 2019, crime 2019, leave it along. Okay, hit save. Yay, it worked. Alright, so now we want to join our tabulate intersects to this table and then use it to populate these fields. So go up to table and join, add join. So the table receiving the information is going to be our neighborhoods here. So that's the input table. The common field between those two is our primary neighborhood name. And we want the 2010 tabulate intersect. And so you have a smart enough to know, hey, you have a field that has the exact same name. So it shows it, which is great. And then just hit OK. And then we're going to use the field calculator here and grab this count data. So there, right click, field calculate. And then go to the end, join your point count, double click on it, it pops up, and then hit OK. So we're grabbing this point count, putting it there. So now remove that join, we no longer need the field. So go up there, remove joins, yes. So table and joins, and now we want to join together our 2019 data. So make sure your table is highlighted. Go up to table, joins, add join. This time choose your 2019. And the field is primary neighbor, primary neighborhood. All right, and hit OK. Do the same thing, go to crime 2019, right click, calculate field, highlight and delete what's in there. Go down to your point count here, double click, pops up here, and then hit OK. So now we have our crimes in the neighborhoods for each of the years. Go back up to, if for some reason you get off of this, click on table, table, joins, remove all joins, remove it. Okay, so now we have the crimes for each of the years. So if we wanted to calculate, say we're interested in calculating the percent change between these 2 years. So we want to add another column here. So add, and I'm trying to see, I'll call it PER change. PER change. And this is going to have decimal points to it, so we want it to be a double. Okay? Now hit save. So we're going to calculate the percent change. Alright, so go over to your percent change and go to field calculate. Alright, so for this, what we want to do is we want to calculate the percent change by dividing the 2019 total crime by the 2010 crime and multiplying by 100. So I'm going to put a parenthesis here and find our 2019. Divide that, hit the divide button there, by 2010. There we go. And then this times 100. One thing before we do this though is there might be some neighborhoods that have 0 crimes in 2010. So let's look. Okay, there's not. So remember, we can't divide by 0. We'll run into issues if we divide by 0. So we don't have to worry about that at all. So now we can just hit OK. All right, so this is our percent change for the neighborhoods. So let's make a map. Let's visualize this, because what's the point of making it spatial if we can't see it? So right click on your neighborhoods and go down to Symbolology. And instead of single symbol, let's get graduated colors. Okay. All right, so we need for our field to check get the percent change. Okay, so we got our right field. One thing is I don't need all of these decimal points, by decimal points. So really we only need maybe none. So to change the number of decimal points that are displayed, you can go up to this advanced options here, and you can go to format labels, and here you can reduce the number of decimal points. I really don't think we need any, so we'll put 0. Okay, and then we'll go back and we can look at the percent change. Okay. One thing is that there should be some negatives here. You're like, but there's no negatives. Crime had to go down somewhere. Well, we have to actually modify our formula to do that. So open up your attribute table again and go to your percent change and right click on it and go to calculate field. So if we want to get where the crime goes down, you know, it to be negative, we have to subtract by 100. So put another parenthesis here, put a parenthesis at the end, and then minus 100. Because if we do it this way, 0% change is 0, and then if we subtract by 100, we'll get negatives and positives. So hit OK. Okay. And so now we should see some negatives here. Yep, we do have some negatives. So we do have some decreases in crime. So now we want to display that. So just if your symbology wasn't there, remember right click symbology. Come back here, and in order to update the percent change, I just choose another field and then go back to percent change. Okay, so now we do see some changes here. One thing I probably would do is like change this to 6. And I want to change this color so they're diverting. Like I'll choose something like that. And I want one of these breaks to be exactly at 0. So maybe I change this one. I can double click on it and put 0. And so now I know if there's like this kind of purple and these pinks, I can even make this, if I right click on it, I can make it some type of pinky purple. There we go. So when I look at my map, I know that this color is associated with a decrease in crime, this color is associated with a decrease, and this. And then everything above here that has pink shades is associated with an increase in crime. So looking at this map, it looks like there's a lot of reductions in crime. Some pretty big, big ones in these teal areas. Right here, though, crime has definitely increased in 2019 compared to 2010. Okay? So we know where there's an increasing problem. And so these neighborhoods maybe would be ones to target because it has increased. Why? I'm not showing you which neighborhood has the most crime. That's something for you to figure out in your exercise. I also have a bonus points for figuring out the relative change. So if you can figure out, the bonus question is, which neighborhood had the biggest relative change in reductions of crime. So we calculated the percent change. There is a way to calculate the relative change if you do some Googling. So see if you can figure that out if you want some extra credit points. All right. So the next part that we're going to move on to is looking at socioeconomic data, trying to understand why crime is happening if it's associated with any of the socioeconomic data. So turn on your Chicago ZCTA. You may be wondering what the heck does that mean? These are actually zip codes. So the ACS data, census data, remember it's collected at different scales. We've been using block group. I just figured we'd use zip codes because it gives us something different to look at. And so if we right click and look at the attribute table here, you'll see this is kind of this is the zip code right here. This is unique. I have checked it to make sure that it is unique. Later you will need a unique ID for the regression, and I've just basically put the zip code in the regression ID column. So what we have here is we have population size, median income, the percent of homes that are vacant, the percent of homes that have a home owner. So rather than being rented, what percent of the homes where the owner lives there, the median age of a zip code, the percent of single mothers within the zip code, the percent of people who have no GED, so basically no high school, less than a high school education. The percent that are foreign born, so this can include U.S. residents that were actually born abroad. It can include U.S. residents that were naturalized, so they got here and then became U.S. residents, or, you know, non-U.S. citizens. So our goal is to look at and see, you know, if these are related to crime. One thing you'll notice is we don't have the crime counts in here. So we're going to need to get the crime counts into this database so we can see what the relationship is. Okay. So I'm just looking. One of the things that you can do is we can just visualize some of this information. So there's this median income. Let's symbolize by that. So let's look at our data here first. Symbolize. Let's go up to graduated colors, and for our field, let's choose income. Let's choose 3 classes. Okay. Just gonna close this because I want to actually see my map. Just looking at our colors here. Let's go with maybe this blue. Okay. All right, so this is income. We can see that the places with the highest median incomes here are in blue. Places with lower incomes, we're only looking at 3 categories here, are in yellow. So why don't you right-click and copy this? And so let's paste it again. Let's paste it in there. And let's change the symbology on this one to something besides income. Let's look at percent no GED. So change it to that. Okay. So now you're looking at the percent of people within these areas that have no GED. And you can see the blue is the higher areas with no GED, and the yellow is the lower areas with no GED. One like symbology trick that you can do is when we have this highlighted, you can go up to, I believe it's feature layer, and you can use this layer blend, and you can go down to multiply. And what this will do is it'll allow you to see, kind of see through your data, and it's really kind of multiplying this median income and the percent GED. So one thing that you'll notice is, let me turn this off and turn this on. See these, this is pretty dark out here. Turn this one back on. And this is kind of, you know, it's in the middle category. So when you multiply those two together, this area gets really pretty dark out here because you're multiplying this high category by this middle category. So you get this darker shade of color. If we look at, say, this area here, we do have a dark blue here, but when we look at our percent no GED, it's very small here. You know, so when we multiply this dark blue by this yellow, it's like a greeny color. It's not as dark as this one, but it's a greeny color. Okay, so this allows you as a way to kind of multiply layers together to kind of see where they might be high high, low low, things like that. So let's look at one thing I was looking at here. Okay, see this little one right here? It's yellow, so it's really low for percent GED. We'll turn on really low for median income, and when we combine the two, it stays really low. It's actually the only place now that has low percent GED and, quite oddly, low income. So that layer blend can be very useful, and I just did it to the Chicago layer so it multiplies. The other thing maybe you noticed is now I can actually also see through it, so I can see the base map of Chicago under here if I really wanted to. So I'm just going to turn it off and go back to normal. But I mean, GIS does have some art to it. I don't claim to be an artist, but it's fun making maps and visualizing the data. Visualization is very important. Okay, All right, so the next thing that we want to do is we want to get our crime data into our socioeconomic data. So this is the exact same process that we used, this tabulate. And so go up to Analysis, Tools, Toolbox, Analysis, Statistics, Tabulate Intersection. And this time let's just worry about the 2019 data. So we're going to do this on our one thing that you notice is, see how this has a nat, this has Chicago, your zip codes, it has a 1 after it, and you also see it down here and it has a 2 after it. It's doing that because remember we copy and pasted in the layer, so we actually have it in there twice. To keep things more clear, I'm just going to remove this other one that I pasted in there. That way we only have 1 in there when we try to do all this stuff. So tabulate intersection, Chicago, our zip codes. Our field is that zip code, so ZCTA 5CE10. And choose your 2019 crime. All right. And for this, again, I could call this, maybe I'll call it zip. I lost my backspace. Zip tab 2019. And then hit enter. Or click off of it. Okay. All right. And then just hit run. So what we're doing is, just like with the neighborhoods, we're calculating the total number of crimes from 2019 that occur within our zip codes. So I'm actually going to follow this through and let this run so that we can have our tabulate down here and go through the process. So I'm just going to pause the video for a little bit while this runs and then come back. Alright, so now it has run, and like before we have a table here that gives us our zip codes and how much crime occurred. So now we need to join it to our socioeconomic data. So right click on your zip code layer. We need to add a field for the crime, so add data and call it crime 2019. You can leave it alone. Then go up and hit save. Alright, close. Alright, then do the join. And we want our zip tabulation. And that ZCTA 5CE10, that's the field that they have in common. Hit OK. Go to the end of your table. And now we want to grab this count and put it in our new crime field. So go to your crime field, right click, field calculate, go down to your percentage count, double click on that, get it in there. And then, so what you're saying is that 2000, that's crime 19 is going to be filled with this point count. Hit OK. Alright, we see that it is in fact transferred over. Notice that the nulls turn to zeros. Ooh, again, are these really no crimes or is it missing data? I don't know. Probably, maybe it could be no crimes. I'm not sure where these are located. I mean, it could be a crime of 0. And this data set seems to be pretty robust, so I'm likely to believe that it is. And the other thing, they're both way up here, so just that's something to note. Alright, so remove the join and then hit clear. Okay, alright, and so if we want to compare really across these zip codes, the count isn't the best way to do it because some zip codes are larger than other zip codes. Some people have, some zip codes have more people than others. So in this case, we're really worried about the differences in the number of people that live in these zip codes rather than the area. So what we want to do is we want to normalize the crime rates by the populations within these zip codes. All right, so we want to calculate a crime rate, so the number of crimes per person. So we need to add a field, and we're going to, interesting, call it CRIMRT 2019. But in this alias field, I'll call it something that's more useful. I'm going to call it crime rate 2019. We have to call it something shorter in this field because ArcGIS doesn't allow names that long. But the alias field can really be really helpful for putting in meaningful names. I've already seen some students take shortcuts and not fill out this alias field. Bad idea. Take the time, fill it out, and give it something that is going to be useful. If you think that you can't understand what this other thing is, these other columns are, change this. You can always change this. You can never change your field name. Once you've made a field name, it's there. You either have to delete the field and create a new one, or just live with whatever name you gave it. So we're going to make this a double because it is going to be percentage. It's going to have decimal points. So hit save. All right. I don't know why this opened up here, but I'm just going to click close. All right. And so my table is actually down here. I'm going to go to the end of my table, my socioeconomic information, and I'm going to calculate the crime rate. So the crime rate is going to be the total crime in 2019 divided by the population. So field calculate. Delete what's in here. I'm going to do crime divided by, and we do have a field called population size. All right, and then hit OK. All right, so now we have a crime rate, so the number of crimes per person, and we can compare them across the zip codes more easily. So if I right click, go to symbology, just kind of take a look at what this looks like, go down to crime rate, and I'll change this to 5. Interesting, okay. Just playing around, okay. Because when we look at the total count of crimes, that's what it looks like. But when we adjust for a number of people who live in these areas, that's what it looks like. So, you know, again, thinking about how you display your data, you can tell stories that are really incorrect, or you can tell stories that are correct based on how you display your data. One thing that's interesting is I'm going to make this a little bit transparent here. It looks like, as I suspected, yes, there is a major road that goes along here, and I wonder if this is part of the L train route in Chicago. There's an elevated train route. I know one goes up here to O'Hare, but you know, getting on the highway and getting out of where you might have criminal activity may be influencing why you have this band of crime along here. I don't know, but I just thought it was really interesting when it popped up. It's like, oh, where's that freeway, the getaway? Ha ha ha, there it is. But that's not in our database. All right, so now that we've created that, I would like you to send me a picture of your 2019 crime rate map. I would like you to turn on the labels here for the zip codes, because later you're going to have to identify which of these zip codes have a hotspot to them. And one of the ways to do that is to have this layer up with the labels on, and then have your hotspot layer we're going to make on top of it. So remember to do that. You go down to label, and if it doesn't automatically choose it, you can go up to labeling here, and here it shows the GIS join, and change it to zip codes, and there you have your zip code labeled. All right, so I would like you to make a map and send it to me. Remember, to make a map, you go to insert new layout. Letter is probably the best way to do this. and then you insert your data frame. I'm just going to turn off these labels here. Insert your data frame. Remember to insert a legend. Now remember, this is way too many decimal points. I don't want to see this many decimal points. I want to see one decimal point in your map. Remember to put a title on here, and the title should say what data it is I'm looking at, and it should say by Dr. Schmidt or by whatever your name is, and then send it to me. So it needs to include a title, it needs to include your name, and then not so many decimal points here. And remember to turn on the zip code labels. Okay? Alright, so now we're going to do a hotspot analysis first. We want to see, okay, we have, where the rates are highest, but we want to do a hotspot analysis. And in the document that I gave you for this week, it talks about this hotspot analysis, GI star statistics. And so this tool is helpful for you to assess whether patterns you see in the data are the result of real spatial processes at work or just random chance. So it's a statistical test that we can use to figure out if there are hot spots or even cold spots for crime. Alright, so what I want you to do is we're going to export our Chicago zip code into a new shapefile called Chicago zip code but underscore crime on the end of it. So I'll get this out of the way. Make sure nothing is selected, remember. Right click, data, export features. Alright. Trying to remember. Chicago crime. Okay. Alright. We're going to call this Chicago underscore ZCTA underscore NAD underscore crime. And hit save. Hit OK. Alright, so we have our new layer here, okay? Let's just turn this other one off. Alright, so let's do our hotspot analysis. So go up to Analysis, Tools, and let's just use the Find Tools option this time so we can just search for it. And put hotspot, oh, it comes up there, hotspot analysis right here. So if you're curious about where it's located, you can click on the Spatial Statistics tool, and it looks like it's down in Spatial Statistics tool, Mapping Clusters, and there it is. So double click on it. Alright, so your input feature class, when this comes up, is going to be that new layer that we just created. Okay. Input feature class is going to be your Chicago zip code crime. The input field is going to be your crime count. So it's not going to be your rate, it's going to be your count of crimes. Alright, your output feature class, I'm going to go to my folder and let's see, call this, let's see, actually have it in my document here what I want to call it. Zip code underscore crime underscore hot underscore spot. Alright. And for the distance, I'm going to put half a mile. This data is actually in feet. Let's see if I can show you why I know that, because we go to source, we go to spatial reference, and the linear unit that the data is in is feet. So if you're ever curious, look at the projection. And so half a mile is 2,640 feet. So I'm going to put in for this 2640. Okay? Alright, leave everything else the same, Euclidean distance, okay? And now hit run. Okay. All right, so looking at this, there are really no cold spots for crime. So areas where you kind of have a lower than expected crime rate. You do have some hot spots for crime here. So and you have a really high one here. They're very confident that this zip code is a hot spot for crime. We're 95%. Remember, this is statistics, so this would be at, you know, a p-value of 0.05. We're confident that these 4 here are hot spots for crime. We're 99, or at a p-value of 0.01, confident that this one is definitely a hot spot, and then less so about these ones over here, 90%. So let's you know, drop that down, and let's see what this looks like if we turn back on our crime rate map. So just kind of looking at the two. Okay, so you can also kind of use this swipe. Let's see if it'll work. Oh, it is swiping. I see it swiping underneath here. Let me see if I can get this swipe. Ah, there we go. Okay, so now I can get the swipe to work. So I got the swipe to work by clicking on the top layer, hotspot, and going up and turning on the swipe, and then I can kind of go back and forth and see, okay, the crime rate's pretty high here, here, there, and there. And what if I change this visualization here to actually be the count, which we use, so the count. So crime. Okay, and let's take a look at that. Okay. Okay. So just, I mean, that's the power of statistics, is just looking at the map. I wouldn't be able to tell you that, oh, my hotspots are here, you know, in here. But with doing some statistics and looking at spatial patterns, it can tell you where the hotspots are located. I'm just curious if I increase these classifications, what this looks like. I just like to play with data. So turn this off. Okay, so the pink here is the pretty high one, and it just changed this to a color that I can definitely see. Okay, so now we can kind of start to see why these might be hot spots. I probably should have used something over here other than orange, since the layer underneath is orange. Why don't I turn it to black? If I can. Ah, it's being very slow. Come on, change to black. There we go. Okay. All right, so I can see my black counties. All right, black zip codes. So turn on the top one and the swipe. Okay. So anyway, there's how you would do a hotspot analysis. So to, you know, run some statistics, to be a statistically significant hotspot, a feature will have a high value and be surrounded by other features with high values as well too. So when we do go back and forth, we see that, you know, there's lots of pink and black around these. You can see the black and pink. So the black ones are definitely surrounded by pink values, which have higher rates of crime. Okay, so that's a very powerful statistical analysis that you can do with the program. And so now I do have some questions as far as you to identify which zip codes would you prioritize, you know, for maybe some outreach, some hotspots. So what I want from you is that a list of the ZCTA 5CE10 that are associated with these hotspots. All right, so now we've done this analysis. As with any data set, there could be outliers. So there is a tool in ArcGIS to look for outliers, cluster and outlier analysis. So like the hotspot tool, it identifies clusters. I'll make this bigger maybe. But this tool also points out outliers of high values surrounded by low values. So high values surrounded by low values, or low values surrounded by high values. Okay? And so we're checking to see if there's a statistical outlier versus just something that could be random. All right. So a spatial outlier. Move this over here. Okay. All right. So to do this, what I'd like you to do is let's copy this crime layer and paste it in here. Paste. Okay. Just so we have another layer here. And I'm looking at this, and we just have it as the pure crime count, so that's good. Okay. All right, so now we need to find this layer. So go up to analysis, or find this tool. Go up to analysis here, and up here click type outlier. All right. And down here we see cluster and outlier analysis. So double click on this. I'm just going to go back there and make this wider. So you can hover over it and it'll give you a little description of what it's all about. You can also right click on it and go down to help. And if you right click help, it'll open up the website that talks about what this tool actually does. So this is a statistical tool, so it is going to deal with z-scores and p-values and tell you about what is happening, high versus low. So if you want to find out more information about these specific tools, that's the way that you can do that. So let's double click on this tool. Okay, so our input feature class, let's just rename this outliers over here. So it was our copied layer. Rename it outliers. And if you do have this like pinned down, what you can do is just drag this over and drop it in there. You know, with ArcGIS, there are many ways to do things. So you could either go here and select it, or you can click and you can drag it in there. Okay? All right, so our input field is going to again be our crime count. And let's save it somewhere. So I'm going to call it outliers _ crime. If I was going to do another year, I'd put the year on it, but just we don't need the year. Okay. All right. And so all the rest of this you can just save. Don't mess with anything else. We'll let the defaults go and hit run. All right, so let's look at our map here. I'm going to right click and say zoom to layer. Okay. So you can see that the outliers are going to be in bright red and bright blue, and just kind of the clusters of high crime activity and low crime activity are in the lighter reds and blue shades. So we can see we actually have no situations where we have a high-low interaction going on, but we do have some situations where we have a low-high. So that points out outliers where high values surrounded by low values. Okay, so let's turn back on our crime that has our counts here and go and have your outlier crime highlighted, and let's use that swipe tool again so we can just kind of see what this looks like. So I'm looking at this. Okay. Alright, I see some things. I'm going to turn off my outlier crimes. So these two right here, they're pretty low. They look like they're around 42 here. So really, really low, but they're surrounded by really high. They're surrounded by the top two categories here. You know, in these two categories you have 42 to 115 crimes. Here you have over 6,000, over 9,000. So when we look at our analysis, sure enough, this area is a low-high outlier because it's surrounded by a lot of crime, but for some reason it just poof suddenly drops off here. I don't know Chicago well enough to know what's going on. Why? Well, one thing that I'm seeing here is that neither of these touch the freeway. So if this was your getaway, they're not touching it, but neither does this one either. There might be another major route going south. No, there's not. So this is where working with your local residents, government, figure out why we have lower than expected crime and outlier in these two zip codes. So yeah, that's how you would do an outlier analysis, and maybe we can learn something from these zip codes. You know, if it's not just simply not connected to the major expressway, if there's something people have done in those areas to get their crime rates down, maybe it could be, you know, a learning lesson. All right. So now we're going to move into regression. So if we turn this off, and I'm going to look at our database here, our socioeconomic database in the Chicago zip code. I went to the ACS data, the American Community Survey data, and found all of this information. I decided not to have you guys do it all. And so I built this data set, pulling together different socioeconomic characteristics that theoretically could be associated with crime. So now we actually want to do multiple regression analysis, because it's multiple, because we have 1, 2, 3, 4, 5, 6, 7, 8 items that we could be putting in our model to try to predict crime rates. Okay? So in the guide that I have, I talk a little bit about multiple regression. Ordinary least squares linear regression is what this is called. You know, if it's been a while since you've done regression, that's okay. But basically, we're building a model that tries to predict our crime. Okay. And so again, if you want to have more information, there's some links here, but also we can do it in ArcGIS. So let's go back to ArcGIS. And this is a tool. So if I have it open, I could just search here, but if you don't, tools, come over here and search for ordinary. Ordinary comes up right there, ordinary least squares. All right, so let's see if we're interested in where it is. It's under spatial statistics tools. It's under modeling spatial relationships and ordinary least squares, so double click on that. All right, so our input feature class is going to be our crime layer, so the Chicago zip codes crime. Our unique field is going to be our regression ID. All right, and let's save this file. I'm going to call it zip. I'm just going to kind of copy this down here, and then zip code OLS underscore regression. Okay. All right. So our dependent variable is the thing that we're trying to predict So in this case, we're trying to predict the crime. So not the rate, but the crime. All right. And our explanatory variables are socioeconomic characteristics that we think predict crime. I'm going to leave population size off for this one. Just because I don't really think it's very useful. I mean, if it comes up significant, what are you going to do? Say, people stop breeding, or no more people in this zip code. When you're doing models, I mean, you got to use some common sense. What makes sense to go in the model, and what makes sense as far as trying to apply it or use it or learn lessons. I mean, knowing that you have more crime where there's more people isn't really overly interesting. You also have to worry about when you're modeling if things are correlated. So if you don't have a good argument for having it in your model, you know, a variable, leave it out. All right, so median income, percent of homes that are vacant, percent of homes that are actually owned rather than rented out, median age of people in the zip codes, percent single mothers, percent with no GED, and percent foreign born. And you do want to save your output file because this will tell you the results from your regression. So click here. All right. And I don't know, I'm going to, let's see, summary. OLS crime. Okay. And then just hit enter. Alrighty. So now we are ready to go. Hit and run. Alright, so this over here, close this. Alright, so it does create us a shapefile so we can spatially see what's going on here. It defaults to this standardized residuals, and basically the residuals kind of give us an idea of model fit, where it's fitting better than other areas. So you'll see these areas, it's either tending to overpredict or underpredict crimes, and these blue areas again are overpredicting or underpredicting crime. So let's see. Let's right click on here and let's look at our attribute table. So it created a new file, and so we have our original crime. We have our socioeconomic characteristics, 1, 2, 3, 4, 5, 6, 7, so all of them are included. And the estimated is the predicted crime. And the residual kind of gets at the amount of error, and a standardized residual is again gets at the amount of error. All right. So I want to just visualize this a little bit differently, so I'm going to copy this and paste it. Okay, I want to leave this one here. Check this off, check this off. Alright, just getting things closed here. Alright, I want to look at the symbology. And let's see, let's look at the estimated. Okay, so this is the estimated crimes. And you'll see that the areas that were identified kind of as hot spots here are still hot. Here and here. One thing that's a little interesting is predicting negative crime. You can't really predict negative crime. So in that case, the model is a little wonky. It has to do with going through the intercept. But you know, you can see some of the patterns do still hold up here. So if we go back to our other crime layer and turn that on, turn this off, you know, we can see that this band of red that kind of goes along here is associated with higher crimes here. So, you know, it did predict the amounts of crimes. And so how good is our model? We did save the report, so go down like to your Windows Explorer, find your folders here. Alright, and I believe I saved it In my GIS, I know that folder isn't empty. I think I was under C, GIS, Chicago crime, and right here. All right, and so this will give you a whole big PDF, you know, where you can see the model results here, which ones are statistically significant. They'll have the little asterisks next to them. So if they have p-values greater than 0.005, they're probably going to be statistically significant. So looking at this probability p column, and by the coefficient, you can tell which ones positively and negatively influence crime. So I will ask you to send me some screenshots and some information there. Here's where we have some diagnostics. So we can look, and you know, our R squared is actually really high. 0.58 is a really high R square, and it's basically telling us how well the model fits the data. So you know, it's telling us that it's a pretty good model with that good of an R squared. So overall, the model actually did really well. This is just some information about what the distributions look like. You know, with any modeling, there's assumptions that go into models. Lots of them have the assumptions of normality. This is not normally distributed. It should be a nice bell curve if it was normally distributed. I mean, this isn't too bad, the percent homeowner. Median age isn't too bad. You have fewer older people, a lot of younger people. Looks like it's a younger population. Crime is very much skewed. You know, you have a lot of lower values and a few higher values. But these are diagnostics that you can do. The residuals actually look really good. They're normally distributed here, so it's a nice bell curve like I was talking about. So, yep. So it looks good. Residual versus predicted plot. Again, these are just a lot of diagnostics that you can do. And it's pretty good. So the blue is where it's under predicting, which is what I thought, and the red is where it's over predicting. So the residuals don't look too bad. I don't see trends in these, which is good. So if we go back to our map here and we turn on the original one, so it's over predicting crime in these red areas and under predicting crime in these blue areas, according to our modeling results. So yeah, pretty helpful and useful tool. So some regression analysis in ArcGIS. All right, so for our last thing, hang in there, we were interested in parks, and people are like, parks are going to increase crime in our area. Well, let's see, we can actually do some statistical work to see if parks really are associated with increased criminal activity. All right, so we have a parks layer here. Park boundaries, Chicago. Chicago has a lot of parks. Let's look at our attribute table. How many parks does Chicago have? 617. So a lot of parks. And you can even see if they have baseball fields, basketball. Pretty cool database that they have. It does have an acres column. So this is how big the parks are. So we're interested to know if there's a relationship between the number of crimes and how big a park is. So if you have like more park within a half-mile radius, are you going to have more crime? Okay. So to do this, we're going to use a tool called Summarize Nearby. So go up your tools and toolboxes and go up to the top, and it's actually under Analysis Tools, Statistics, and it's called Summarize Nearby. All right. So what we're going to do is our input features are going to be our parks, and our input summary features are going to be our crime data, our points. Turn it on over here, our points. All right. And so I already did save this, but you could call it parks boundaries underscore Chicago. I just left the NAD 83 on there. NAD 83. Summarize nearby. That way I kind of remember what I did. And it's giving me an error. I'm not exactly sure why. Let's see if I take that out. Oh, it doesn't like this shape on the end of it. Leave that off. Let's try. Just to do a test. See what funkiness is happening. Okay. I'm not sure why it's doing that. For the distance, we're going to put 2640. Alright, and the units is actually going to be feet. Okay. And the rest of the fields you just leave blank. This tool can only be written to a file geodatabase or stored in memory. Ah, okay. I know what that means. Alright. So it wants it to be into a geodatabase or stored in memory. So that means we actually can't save it anywhere. So what's going to have to happen is I'm going to go back out of this and do summarize nearby again. And our input field was our parks. Our features was crime. I'll just leave that where it is because it's storing it in the geodatabase that's associated with this project, and it won't allow us to save it direct as a shape file. So if we want to save it as a shape file for later, we're going to have to export it after it's run. And so just leave that as it is. And now for here, put 2640. Because that's how many feet are in half a mile, and change this to feet. Okay. And then hit run. I'll hit run. This. Hey, my distance went away. 2640. Okay. All right. And this will take a little while, so I'm going to hit run and just yeah, let it go. So hit run. And there it should go. So what this is going to give us is it's going to give us a count of the number of crimes around each park within a half-mile buffer. All right, so our analysis is complete. So let's look at our newly created file here. Right-click and go to the attribute table. All right, we see our parks here, 617 of them. And at the end, we should have a count of points. So the count of points is going to be the number of crimes that occurred within our buffer distance of half a mile. And so now we want to do a scatter plot, an XY scatter plot, where we can see if there's a relationship between the size of the park and the number of crimes that occur nearby. So with this feature, highlighted here, you can go up to data, and you can go to create a chart, and you can go down to scatter plot. Okay, so for the scatter plot, we're interested in acres for our x-axis, because our acres, the size of the park, associated with the number of crimes. So the number of crimes is the count of points. Okay, and so there it is. We see we have a regression, and so this is saying that the x, remember, is acres. So for every additional acre, our model tells us that we get 9 more crimes. And the r squared is 0.233. Okay. Looking at this, it looks like there are some pretty large parks here. So down along here, there just must be a string load of parks down here. Turn these off. yeah, there's some huge park that occurs along here. Okay. All right, so there's a big park there. What is this park? I'm curious. 1,200 acres. Magnet Park. Well, maybe it's a Magnet Park. Oh, the park is Lincoln Park. Lincoln Park has a lot of crime, but Lincoln Park is also very big. So, you know, this is what the relationship between acres and count of points looks like, or this is your count of crimes. If we're interested in, hey, maybe we want to not get rid of these larger parks, I want to see what's happening in more normal sized parks here, one thing you can do is you can click and drag and then select these smaller parks here, so less than 400, let go, and now you can go back up to filter by the selection. Click that, and now we're actually only looking at the smaller parks, so getting rid of those huge parks. Maybe we're more interested in the parks that are, you know, not along the lake here, but out over here. And so here's the relationship there, and it's quite a bit different. The equation still says, you know, about 9 for every acre. The R squared is much, much lower. There's a lot more noise in the data. So that's one way that you can look at these. I'm just going to open up this here, and I want to sort. I'm just looking at the range of sizes. There are some parks with 0 acres, which is kind of odd. One reason I usually never trust the size within that people give me, but I mean, it's a pretty small park. You know, maybe it's within the air of the data. A very small park there. Interesting. So again, turn this off. Pretty small park there. I open this one here, summarized by acres, and now it'll highlight it. So there we go. Small, pretty small park. Another pretty small park there. Okay. All right. So anyway, you have just done clear the selection toggle here to get it back. So that's how you would do, say, an analysis if you're looking at park size and the amount of crimes that occur within half of a mile. And so how you would use the data function and create charts. You could create, other charts of your interest here, bar charts, pie, line, all that. So again, that's the exercise for this week. You can look into the crime analysis document. You'll find some homework questions in there. They will be in red. And so, yeah, good luck on working through your assignment. I'm going to save this. Always be saving. And if you have any questions, let me know. All right. Have at it.